didn't see you there. Welcome to A Day with Newton. I'm your host, Sir Andrew Anabi. Today we will be traveling through history to meet Sir Isaac Newton, born on Christmas Day, 1643. Some may say he was a gift from God. Today we will be exploring his three laws of motion, integral to physics itself. His first law, the law of inertia. His second law, force equals mass times acceleration. And his third law, every action has an equal and opposite reaction, acting on two different objects and do not add up to zero. These laws will be presented by Dr. Daniel Foley, Dr. Connor Maloney, and Mr. Michael Paolella. Hopefully, we will get a better view on Newton's laws today than we ever have before. Oh, look what... Oh, you're a sly one. Today, we're going to be demonstrating Newton's first law, the law of inertia. You see, this law could be explained in two separate statements. The first is that an object stays in whatever state it's at until an external force acts upon it to change that state. The second statement is that when the total force, the net force, equals zero, and the object is staying still, the object will continue to stay still until an outside force acts upon it. If the object is moving and the F net equals zero, the object will continue to move at a constant velocity until an external force acts upon it. Here to demonstrate this law with the tried and true cup and inertial coin method is Dr. Connor Maloney. Dr. Maloney.
Thank you.
Please explain.
As you can see, flicking the card quickly results in the coin falling down into the cup.
Due to what force?
Gravitational force.
Thank you, Dr. Maloney. Stop. Look what time it is. It's time to learn. Today we're going to be discussing Newton's second law. Force equals mass times acceleration. Here to demonstrate that law is Mr. Michael Paolella. Mr. Paolella.
Here we have a coin and a piece of candy. The coin's mass is far greater than the piece of candy's mass. Since they're both accelerating at negative 9.8 meters per second squared, they should both hit the cups of water at the same time. However, since the mass of the coin is greater, it will have more force on the cup of water, demonstrated by the splash.
To demonstrate Newton's third law of motion, it's Dr. Daniel Foley. Dr. Foley?
Hello there. Newton's third law is that for every action there is an equal and an opposite reaction between two forces that do not add up to zero. If I kick this wall sitting in this chair with 250 newtons of force, it will push me back with 250 newtons of force. Such as this. I'm rolling because it pushed me back.
It's a masterful novel, but not as masterful as the tour we just took learning about Isaac Newton. He was a great scientist, and his laws caused physics to become what it is today. I hope you learned a lot today, and I hope Newton's image resounds throughout the years to the minds of those old and young. For me, Sir Andrew Anabi, Dr. Foley, Dr. Maloney, and Mr. Paolella, have a good night.
But wait! There's more!
Hi there. So it turns out, we needed 6 examples of Newton's laws, and what you just saw was only 3. What we're going to have to do is show you 3 new examples of Newton's laws of motion, including the first law, second law, and third law. So be prepared to learn even more than you were prepared to learn before.
$1 million.
Here to demonstrate Newton's first law of motion is Dr. Connor Maloney. He's going to demonstrate the ability to catch a coin placed on his elbow. Dr. Maloney.
Thank you, Sir Nabi. First, I shall place the coin on my elbow. Then I will remove my elbow from the coin. The net force shall bring the coin downwards. If I am fast enough, I shall catch the coin. Do you believe I'm fast enough that I can catch the coin? We'll find out.
I just have to believe.
Welcome back to Newton's second law of motion. Force equals mass times acceleration.
Hello. My right fist and my left fist have the same mass, but if I accelerate my left fist faster than my right fist, you will see the dent on the can due to the greater force.
Welcome to our second example of Newton's third law of motion. For every action, there is an equal and opposite reaction.
See, the force that the balloon is pushing the air out with is equal to the air pushing the balloon forward. So when I let this go, the balloon should shoot forward.
Go home, folks.
Do you think I'm fast enough? Guess not.
You're a sly one.
Connor!
Welcome to our second example of Newton's third law of motion. For every action...
I'm sorry. End it. Oh, I just continued it, didn't I?
Welcome to our second example of Newton's third law of motion.
I'm sorry, yo. I can't do it. I can't.
Welcome to our second example